Well, good morning. I'm going to try to rally the crowd back together here. Actually, sitting in this morning on the beginning of the conference, there was a moment where I thought, this could end very, very badly. When I saw all the dignitaries, including the minister, simultaneously touch these electronic lamps, my inner engineer couldn't resist to ask myself the question, so how much voltage is on those? And so, a mass electrocution would certainly have given a lot of attention to our industry, but maybe not quite build the brand that you were looking for. And so I'd rather highlight the fact electronics did work, as it pretty much always does, and they were able to light the lamp in the light of this industry. But there was another comment that caught my attention by the opening speaker, who said something along the lines that the expectation is that by 2020, the amount of import of semiconductor will be higher than the dollar amount of oil import. Well, that should get our attention for sure. And I wish this were true in every country in the world, because then semiconductor industry would finally get the respect that it's due, in contrast to all these energy guys. But the fact is, we are very much at the center of gravity of an industry that has major impact of the future, not only of this region, country, but of the world, period. And so in that context, the theme that I would like to talk about is the theme of techonomics, the intersection of technology and economics as being absolutely central in how to think about the challenges ahead. And in that context, I would like to propose to you a dozen or so vignettes that are ways to think about it in general terms and that have proven over time to be quite effective. And the first one of these vignettes aims at the economic side of things, and it is the realization that technology and economics are highly intertwined. The second one has to do with the question of how do you actually play in this field. So let's start with the first one and do it via the pathway of looking at the history of recent, meaning the last 30 or 40 years or so, microelectronics. And what we clearly can see is that there has been an enormously rapid evolution in what electronics have brought about. Clearly, semiconductors have had their inception or their biggest growth initially in computation. The PC was the symbol for that, but that, of course, also had a major other impact. It brought about the entire software industry. And it's then in the 90s really that mobile communication became a very key ingredient. And many of you may remember that we coined the term convergence, which was very exciting at that time. Today is almost old hat, because these two things have absolutely come together. And your phone today is actually a mega computer in your pocket. Now with that came, of course, the networking infrastructure underneath that and the software equivalent of the World Wide Web. I don't have to tell you that this, in terms, resulted into a massive socio-economic change of how our population, and especially our children, interact and learn, and will have massive impact going forward, especially amended by the fact that video has become one of the absolutely key drivers of utilization of semiconductor bandwidth and so on. And that we are now facing the age of sensors becoming the new input to this network as well. Luckily enough, from a technology point of view, we've moved fast forward, and it's not just a computer that you have in your chip. You have actually a multi-core device, many specialized compute engines, and I predict for you that in this coming decade, we're going to go into the age of smart everything, meaning it from your toaster, your keychain, your child, your dog, everything that has value will at some point in time be connected and have some IQ attached to it. Well, the effect of all of this is that if you look at the content of semiconductors in electronics, it has remarkably so continued to grow. And I must say I've been surprised that it actually passed even the 20% point. But on the other hand, you can say you look at what you have in your pocket, it's really a set of chips surrounded with a little keyboard, a screen, and some plastic. The content is very much in the semiconductor arena. This, of course, is the impact of what we have just discussed a minute before. Now, in order to play in a market that is moving so rapidly, it is important to understand that if you are not differentiated, you are very quickly relegated to a non-player in this market. And so if we look at differentiation, in my opinion, it has fundamentally three dimensions. Either you build something that is better than the other guy, or you are sooner to market with some capabilities, or you are cheaper. It's a very simple recipe. Maybe it sounds too simplistic, but I would propose to you that this applies to companies, to individual endeavors, and to countries as well. It's also interesting to look at the fact that as you go through economics ups and downturns, there's actually a wheel that turns around this. Just imagine the 2008 downturn. Immediately, the entire focus was on cost reduction every possible way. But simultaneously, a whole new effort started, which is the invention of something truly better. From there, very quickly, other people catch on, and now the race is on to the market with multiple products. And of course, the loop closes again, doing essentially the same products, but now dramatically cheaper. And what better example in the last 2.5 years than the iPad for this? I'll remind you that the evening before and the morning of the introduction of the iPad, 90+% of the professional pundits writing about this all agreed on one thing. This is a boring product, way too big to make a phone call on, and by the way, who wants to touch a screen and leave smudges behind? 4 weeks later, multiple thousand of applications. 12 months later, 130 pads in design, and we know many of them very well. And of course, not that long ago, here in India, a very, very cost-effective pad that, yes, is not quite the same yet, but is very rapidly moving in the right direction. So this trio of better, sooner, cheaper is absolutely fundamental in high tech, especially when you consider the notion of speed and execution. Now, I don't have to tell you that the markets that we just described are enormously rapidly growing. And this morning we heard just number after number after number of opportunity for India. I would propose to you that too much of a focus of India is actually detrimental. Don't chase yesterday's market. Change where the overall market is going, and at no time underestimate the competition in the rest of the world. But the opposite is true too. At every time, consider the very fact that in all these areas there's enormous growth potential, and specifically in India there's the opportunity to execute on what of the players said, which was US ingenuity plus European quality plus Chinese pricing. But add to that Indian entrepreneurship and ability to assemble and bring together and make cost effective. That is actually a very powerful recipe to take the best of what others can do and assemble it in something of high value. Let me now move for a brief moment to the technical side of this. And here two concepts that I would like to highlight. One is scale complexity. The other is the fact that scale complexity is moving to systemic complexity. Now, scale complexity in semiconductors is simply called Moore's law. If you want to have an illustration of that, all you have to do is look at photography or video to realize that the sheer number of pixels, and especially pixels per time unit, has grown just astronomically. Even your grandmother can understand that the bigger picture is better. Well, the electronics underneath that is essentially Moore's law. And the good news is we still see a continuation of traditional Moore's law with smaller and smaller devices. More sophisticated transistors continue for a couple of years. What I would propose to you, though, is that both on the technical side and on the economic side, we're now seeing a shift from scale complexity to systemic complexity. And in a second, I'll explain the symbolism that I'm using here. But if I were to explain systemic complexity in technology terms, I would use an example to say, don't think for a moment about the speed of a device without looking at the power and the signal integrity and the yield. All of these things are completely intertwined. Oh, and by the way, true also hardware and software, completely interdependent. By the way, the same can be said for the economic side. The value chains are completely intertwined. If you have a great chip in a bad phone, you sell zero. If you have a great phone with a so-so operator, you sell zero. If you have a great operator with not sufficient apps, you sell zero. The interdependence is great. Therefore, my symbolism In English, we so often speak about success is the sum of our efforts. It's not. It's the product of our efforts. A single zero and everything has zero. This is true in the value chains. Be careful who you choose as your partners. It is true in the technology. Yes, the details matter too. With other words, anything can stop the shipping of a product. And all you have to do is look at some of the impacts of the tsunami or the floods in Thailand to see that individual pieces, individual components can absolutely shut down a value chain. So systemic complexity is important, and in that context, an example for that is, of course, hardware and software. And if you look here at the design cost, you will quickly see that there is a reason why in most semiconductor companies today already there are more software engineers than hardware engineers. The software content is growing. What is not visible here is the fact that the software and the hardware are not independent. They're actually highly interdependent. And another way of looking at that is from the perspective of time to market or return on investment. What you see here is the cost of designing a communication chip, and there's sort of a hardware phase and a software phase. They're somewhat overlapping, and the big mountain to the right is actually the manufacturing cost. And it's a high mountain because it's a communication chip. It's a high volume chip. But what is interesting in this picture is really the timeline. If you look at the return on investment, initially you just have expenses until you start shipping, and it takes a while before you catch up. And as a matter of fact, in this case, the break over point is about 34 months. With other words, a very long time. And so anything one can do to accelerate this value chain has material impact on the success, on the economic success of it. And therefore, a single issue that stops it can also have disastrous impact. It's not the sum of the efforts, it's the product of the efforts. Let me now move to the third category of vignettes, a few smart engineering steps. And interestingly enough, a number of these were already mentioned this morning, specifically the notion of reuse, and I'll introduce another one, which is the notion of critical mass. If we look at reuse, all you have to do is to look at a sophisticated chip to quickly discover that the number of sophisticated blocks on such a chip is actually quite large. It's also interesting that we have seen a massive move from design everything yourself to increasingly partner with a variety of suppliers or other collaboration entities to get some of these IP pieces. And processor cores today can be readily bought on the market, user interfaces, UI blocks, memories, and so on. And as a matter of fact, Synopsys ourselves, we provide many of these building blocks. My point is not to highlight that. My point is to highlight the fact that reuse is a concept that is fundamental in engineering. It is also fundamental in good business. And as you look at assembling the next generation of value chains in India,